Hello everybody and welcome back. We are back over here on the electronics bench. So, today I need to figure out if my expansion theory using muxes will actually work. So I need to do 2 layers of them that will use, 6 outputs and 2 inputs to read 128 inputs. So I need to prototype that on the breadboard, see if the Arduino Leonardo will actually read it, and how quickly it can actually read things. So if I hit a button, what's the time that it will take to read it versus all the switching through it, and how long is that, and can I do it quick enough that when you hit a button, you'll always get it, and even if you just flick it really quickly, you'll still get it? So I need to wire all that up. We're going to start out with the Leonardo next to it, and we're just going to wire in all of the muxes and see how it goes. Onto the logic. I'm going to build that out, and we'll see you guys in a minute. Okay, let's dive into this monstrosity that I've created. So, there's a lot going on here. I actually like this breadboard. It's actually good. So I really like this thing. It's super neat. I can plug this in, and we'll get some lights and power going. So this is essentially a demonstrator for how I'm going to read so many inputs. So, with these multiplexors, which I'm just going to refer to as muxes because, well, it's simple, easy, it's what they are. I've got one in the beginning, which then reads 8 outputs. 8 of those outputs, or 8 of those inputs, go to the output of these 8 multiplexors over here. And for now, I only have one output wired to them. Well, I only have the output of each of them wired into the first multiplexor, so X0 through X7. That way when I read X7, I'm reading the output of this 8th multiplexor, which this one is actually connected to 4 little circuits over here just to test the input, very similarly to how I'm going to actually wire them up. The first one is basically, it was going to be a switch with an LED, but I bypassed it into a potentiometer, did the same thing with the second potentiometer, and then I have buttons which actually light up when you connect them. And these do actually read, they go into an analog input on the Arduino, and if you digitally read a button, if it's over half value-ish, it will tell you that it's a 1 or a 0, well, a 1 if it's high, or a 0 if it's not. So I can digitally read buttons, but I can analog read potentiometers, and this is actually sending a value out on a baud rate, and I can either interpret that, I can send it out as an axis, or I can do math in here depending on what it is. So if it's something like a rotary switch where it's got 4 different detents, I can calculate the position of this and what rotation it's in, and actually rotate the knob depending on how you actually move it. So that's going to be super helpful. I can do any calculations inside the Arduino with that. And then the buttons are pretty simple, straightforward. And then as far as how an actual mux works, essentially there's VCC, there's power, and then you ground all 3 of these pins. Over here they are 7, 6, and 5. For this specific one, those are essentially your controls, and one of them ignores values, one of them accepts values, etc. And then I have these white ones and these orange ones coming out of the Arduino. Those are actually control pins, and I have them all jumpered with these little green jumpers. So essentially, this first one is getting the first layer of control inputs. So this mux specifically is reading essentially base 2, 3 digits, which gives you 8 numbers that you can read. So you can read X0, X1, X2, X3 using these control pins in binary to specify which one you actually want to pass through into the analog read. Then I've got a second layer which actually creates a second control input where I have to read all 8 of this, shift to the next one of the parent, that way I read the next mux, go through all 8 of those, etc., and it ends up being a 6 times nested for loop in the code, and we'll hop to it in a few minutes. But that code, I don't like nested for loops, and there's 6 of them in there, even though it only goes from 0 to 2. So it only runs every input, every permutation of it, for 2 layers, and there's 6 of those. Even though it's only base 2 and there's only an on and an off position, I still don't like doing that, but it does run pretty quickly. It runs in like 50 milliseconds total to cycle through every input for just these. No, for every input. And the only difference between running 1 cluster of 8 muxes and running 8 clusters of 8 muxes is using 8 input pins versus just 1 input pin. So because I'm limited to 128 inputs, I'm going to have 2 clusters of this in parallel with 2 inputs. But essentially, these two bypass these 2 switches and are just straight going into it. So these 2 are potentiometers, these 2 are literally just buttons that we can push and see an input on the computer. I think right now they're an analog read, but they can be a digital read. And it does read all 64. I'll show you guys what that looks like when it's actually running them for the output, but I'm also going to consolidate it and condense it down into 8. That way you can actually read that there is a potentiometer changing instead of just dumping data, because it dumps a lot of data really quickly. But yeah, that is a good majority of what I've wired on here, and this breadboard, it's the first one I've had that hasn't had floating grounds and misconnected stuff, etc. So I'm really liking this so far. Even though all the jumper wires looks like it's kind of a mess, I used all 4 breadboards. So this is going to be interesting to put onto an actual breadboard and actually do the real soldering and the real work on this, because all these wires have to go in there somewhere. Well, everything left of it, and then all the rest of it's just outputs. But I'm going to have 64 outputs, not 4 outputs. So I've got to figure out where to put 64 wires and how I want to space this and where they even go, because that's a lot of wires and a lot of inputs, and I'm going to have 2 of these. So I've got to figure that out. That's going to be a later video of how I actually put these on a soldered breadboard. But I think for now, we're going to hop over to the computer. I'm going to move you guys, and we are going to show you the potentiometer inputs and outputs and the actual buttons. And then one quick note, the outputs, when they go low, so the inputs are tied to ground. It does have a pull down resistor inside of these muxes. So all inputs, when you turn off the juice to them, they will float low, or they'll get pulled low, so that way you don't get residual voltage. The output, however, is not tied to a ground, so you have to do that yourself. I'm using a 1 mega ohm resistor, because if you use something smaller, it actually acts as a voltage divider, and muxes require, I think it's 4.2 volts to turn on, and I'm only supplying 5 from the Arduino. So I really can't lose a lot from a voltage divider, so I'm using 5 mega ohms. So something like a kilo ohm drops it to like 3 volts or something. I forget, but it didn't work. 220s definitely don't work. But this 5 mega ohm works great, so I'm going to have to use it as a pull down resistor for just these ones on the top, because these guys all go into an input, which actually gets pulled down from the next mux. So that works. But on these very last ones that don't have a pull down, I'm essentially having to tie all my inputs on the Arduino to ground, which makes sense. But it also makes it so that when I'm not listening to something, it won't float and give me false positives. So definitely a good thing. And we're gonna hop over to the computer, because I think that's most of what I was gonna explain. But yeah, there's 5 volts, there's ground, there's my input voltage. The orange controls my second layer, the white controls my first layer of muxes, and we're going to repeat this set of 9 muxes for every 64 inputs. Just depends on which Arduino I plug them into, because this one output, it's just a 1 output for 64 inputs. So yeah, how I organize that, that's another challenge for another day for now. But I'm gonna hop over the computer. We are going to run some numbers, or see some numbers. Okay, so as you can see, we have all the code here on our left. This cycles through the first mux and the second mux and goes through every possible permutation. This delay is there so that I can actually read the numbers going through. So when I change a potentiometer value, I actually have enough time to see that that's 771, not the 500-ish it was at before. And then if I go back, I can actually see that it's dropping and that it dropped. That one's 480-ish. But that's the entire purpose of this delay, just so I can read it, because this is going through 64 inputs, and it will do all of this within 50 milliseconds, and I can't read that fast. Just the output scrolls too quickly. And it'll actually be faster if I don't print this, if I just use the output. So this MUX L1 input is literally just reading the A0 pin, and then these are just my control pins for the first layer of muxes and the second layer of muxes. So this controls all 8 over there, and then L1 is just controlling this mux, soon to be 2 muxes, and each of those will have their own cluster of 8. This initialize goes down and literally just sets the pin mode, sets the state to low, and just initializes all the muxes. All of them at the same time. Or the outputs, the control voltages for them. And then just tells it that this is an input, and then we go through our loop. So every single second, or every single time it goes through as fast as it can, it goes through this code, prints the timestamp, the binary control number, which is essentially just a binary number from 0 to 8. It prints that number to say what mux and what input we're calling, and then sends the value that it's reading there. And since it's an analog read, it's a number between 0 and 1024. If you do a digital read on something like a button, it will actually give you a number between 0 and 1. But right now this one's got a 220 ohm resistor on it so that I don't fry my LED, but it's also acting as a pull down, so it's making it 400. It's making it roughly half value, so I would actually have to read that if I use this resistor. I don't plan to, but it also means that I don't need resistors in a lot of places, and that's just weird. But yeah, so I'm going to change this real quick so that we're only reading the mux that we're interested in, and so that we are printing a little neater so that we can actually see values changing. So I'm going to do that real quick, and we'll be back in just a second. Okay, so now it's only doing this 8 output. Actually, I'm going to move this. Alright, so on this one, now I'm essentially just setting the first mux to only read from mux 8 and just ignore all the rest of the muxes. That's where the hard code is, and then I just don't set the value inside of the for loops. Slight waste of space, but it works. Nah. Then we go through and we cycle through every input on mux 8. But again, it's still really hard to read, especially if I take out that digital read of 50. You just can't see the trends, you can't see the data it's coming through. So I'm going to pretty up this format, and we are going to play with some more buttons again. But you can see this is a much more consolidated, nicer format just for testing this one mux, because now you can see there's a third button pretty quickly, and a fourth button pretty quickly. So now you can see that all 4 were on, and there was even an LED. So I'm going to clean this up, make it pretty, show you guys some of the speed that it's got, and we'll keep going. Okay, so this is running at full berries, quick as it can, and you can see we have 546. This is the first potentiometer. That's off. That's a button. That's off. That's also, well, it might be a button. And then this guy's 480. That's also potentiometer, and then that's kind of just a floating number, not a useful one, but a floating one. And this is running so quickly. This is hundreds and hundreds of times per second. If I stop the auto scrolling, look how many times this is running per, what, 25 milliseconds? So in 25 milliseconds, it's running through probably almost 15 times per 25 milliseconds. So these are about 5 milliseconds to read all of the LEDs, or to read all the inputs. That's kind of impressive. So yeah, just to illustrate the potentiometer and the nice speed, I don't know how well you guys can see it, but you can see that when I twist it all the way to the right, we get 1023, and that's because of the 5 mega ohm resistor, or the 1 mega ohm resistor. If I make it even bigger, it'll be closer to 1024, and that's all the way at 0. And then roughly halfway in the middle is roughly halfway in the middle. Let's see if I can actually hit 512. There's 512. So that's on that one. And then this guy, same thing. It has full resistance, so we can read this number very precisely on the potentiometer and even dial it in exactly where we're looking. So now we got 512 on both, and then if I want to go to like 3/4, go like something like that. Probably not quite like that. Probably there-ish. Huh. But that's one of the joys of it, and then I've got an instant button. And just the value pops up and populates. And apparently I plugged this one into the wrong one because it's reading out of order. Or I'm actually reading the mux one out of order. But that's essentially how the muxes work. It's double nesting through them, reading all of them, and yeah. So I can actually read all these guys at the same time with only one input being used. That's super useful, super handy. I've got to figure out how to somehow get all of this onto a breadboard somehow, and do multiple ones of these, because these control voltages, all these oranges, also go to the second set of muxes, and then these white ones still go to the first set, which is going to be on another breadboard, or I can put them on the same one and break it out somewhere. I have no idea. I'm literally just going to have to draw this out or align breadboards and figure out where I want to put them, how I want to do them, etc. So that's going to be tricky. I might actually do it on an Arduino shield, because 2 muxes on a shield is not bad, but then I still have 16 outputs that I somehow have to get out. That could be tricky. It could just be a hedgehog of a breadboard. But we'll see. So hopefully you guys enjoyed seeing this giant prototype of multi-layer muxing and the outputs from it. Hopefully you guys picked up something. If you've got any advice on how I can wire this into a breadboard, if it's just sit down and grind and just keep soldering, that is probably what I'm gonna have to do. But hopefully you guys got something out of it. Let me know if you guys have any comments, improvements, or if you guys like what's going on. Again, the Patreon links are up, and essentially wherever that poll is sitting, that's probably where we're gonna go next with the cockpit, or at least in the future. And we will see you guys in the next episode.